What we do now is called regression, and not surprisingly it uses the Excel tools, and as usual it has some funny little things to it. Okay, so I've got my data here, you've got television and you've got debt, and I go to the tools, data analysis, and then regression, and then I put in the Y range and the X range. Now remember, Y is the vertical one. Okay, so this direction here is known as Y. This direction here is X. We've got some other names I'm going to give them in a minute, but we'll just talk about them as X and Y. And just notice that it gives them in a different order. They go Y and then X. So it's not intuitive to me. It sort of gives the debt one and then the television one. So quite often, I don't know if my data is always in the same order, so you need to think about what you're doing and make sure you've got your Y and your X the right way round. Now, how do you decide which one is the Y? The Y is the one that you're trying to predict, the one that you're trying to find out. So the thing on the bottom is the thing that's called the independent variable, or the, I can't remember the word I was going to use, the explanatory variable, and the Y one's called the dependent variable or the response variable. So you need to think about it. Are we saying that we think television causes debt, or are we thinking that debt causes television? Now, we have to be really careful about that because we don't really mean causes, because we can't imply causes, and I'll come to that later in the lecture. But in terms of a way of thinking about it to start with, we think, what is it that we think comes first? We think the debt is the thing that might be leading to, the television watching may be leading to the debt. So the television watching is the X range, and the debt is the Y range. Then, just like all of them, we need to choose, you tick labels so long as you've highlighted. Make sure if you do highlight the labels, you tick labels. If you don't highlight the labels, don't tick labels, because either one of the other combinations is going to make it wrong. Don't make constant 0, don't change the confidence level, and then you make your output range is basically just choose a place up there for your output to come to. So we do that, and this is what we get. Now, there's some stuff that you don't need to know about. There's this thing called an ANOVA table, and I've shaded it out because it's not necessary. The only thing that's vaguely useful about it is this significance level here for the F, but if you look, that's exactly the same as the number down there. So you see you've got that 5.90 blah blah, and you've got 5.90 there. And that will always be the case when you have regression just on one predictor. Well, later on, or in other years, you can actually do it where you have more than one thing in the equation. Rather than just have television, you can have, say, television and parents' income or something like that, or television and income, and then look at debt and see how well the two of them behave and so on. But for now we only have one, so we don't need to do the ANOVA table at all. What we do, and for some reason that I can't work out, it always gives the confidence intervals twice. And you'll see those two things there are exactly the same as those two, so just ignore them as well. It must be just some sort of bug in their program. Okay, so we ignore the ANOVA table, and the second set of confidence intervals is redundant. So now let's look at the things that really are important. Okay, so I talked about what isn't important. So to page 7 here. Okay, so I'm going to tell you what they are, and then we're going to interpret them later. Okay, so we are interested in this multiple r and the r squared. Now this value here, the r square, is the square of the multiple r. If you square 0.5539 blah blah blah, it will come to 0.30. Okay, another one that's useful is the number of observations. How could that be useful to you, do you think? It's good for checking that you've got all your data. So what you should always do is have a little flick down, see how many observations you've got, and make sure you've got them all there. And remember, if it goes down to row number 431, that will mean that you've got 430 observations, because the top one is the name. So this is number of observations, and it's useful for checking that you have all the data. Okay. Right, so those are the first ones. Then here we've got our intercept, and what it says is television and coefficient. Because I ticked labels, this thing says television. If I didn't tick labels, I don't know what it would say. It would say something else, but it wouldn't say television. And now if you look back at the graph here, up the top, you probably can't see it, but it says y equals 2581.8 plus x plus 48040. And those numbers there, that number is that number, and this number here is this one. Okay, so when you go to do your quizzes, you need to fit the graph first, and that will give you your equation, and then you do the regression. That way you can make sure you've actually done the right thing. If you get different numbers here, you've either missed out some of the data or you've got your x and y around the wrong way. So in the Proctor Quiz 6, we expect you to print out a graph and this output and interpret it. So you need to be able to do a graph that looks like this, output looks like this, and then write about it afterwards. Okay, so what we need to know there is, so this is the equation or model, and it should be the same as on the graph. Okay, now we've talked about p-values. We've done that for the last 3 lectures. We talked about p-values, and we have a p-value here, and this p-value is pretty much 0, and this is the p-value of the slope. We are not interested in the p-value of the intercept, because in the stuff that we do, because we don't do scientific things, we do things to do with people, the intercept very seldom has any sensible interpretation. So we're only interested in the p-value of the slope and the confidence interval of the slope coefficient. So this is the confidence interval actually it's not really a slope coefficient, never mind, we'll do. Okay, so those are the things that you need to be able to interpret, and when you write up your data, you should write about those 3, this one here, don't talk about the number of observations.